All right, testing. Give me 2 minutes. I'm just going to make sure this audio comes through on the stream. Brand new microphone. Thank you very much. I funded this from all the Solana donations. Thank you so much. Hello, everyone. All right, so audio is working. That's great. Um, I'm going to show you something today that's kind of really personal. I'm going to start opening up about something and an idea that I've had now for the last 3 years. Um, it may not be a surprise to people, but I really do not like GitHub. And if you see me posting a lot and doing all my public talks, I've been talking about that essentially, like, what is the value of GitHub? Why do we have things designed as they are? Because everything has been designed for humans. You'll see me talking about this a lot. Everything that we have today is being built under the false assumption for humans. Now that we have this brand new computer, we can do things. We can reimagine the last 40 years of computing and design it around autonomous agents first. We can design around autonomous agents first, humans second. But to do that, we are going to need to redesign the whole damn stack. And this is Loom. Loom has had a few names. If people know me personally, this is Ferret. Remember the old days when I was back at Canva and I was talking about Ferret? Loom is Ferret. See, I have a deep belief that essentially when a company called Velocity went under, they made something called Fabricator. For those who don't know this, this is the engineering system used by Facebook or Meta. It's also used by Uber as well. And it was open sourced. And it was so ahead of its time. I mean, it was so ahead of its time. And what happened was we essentially, um, GitHub came along, became cool, and then GitLab cloned it. And what we've kind of got now in the land of like software development tools and the development tooling stack is just a whole bunch of really just Kinder Surprise type things. And I feel like all the innovation is gone. Like I haven't really seen any real developer tooling company really pushing the boundaries yet. And that's what I set out to do with Loom. See, there's an idea that I have. If we falsify the last 40 years of design, that where things are designed for humans, that includes things like the IDE, we can reimagine what the IDE looks like in the future. Like, what does an IDE look like in the future? Like, what's at the top of my head is essentially, you think about VS Code. I don't want to be using VS Code. Like I only use VS Code now as like kind of like a file explorer. I might use it here to walk through some of the parts of the code base, but maybe I use GitHub just for now. But what I kind of want to do is kind of reimagine what the IDE of the future is. What is infrastructure where you can program loops? What is infrastructure where you can program loops? What does it mean when you can invalidate 40 years of design? Now, let's start getting into concrete particulars. Ralph Wiggum has popped off, which is lovely. People think that it's just a bash loop. Well, I'd like to put it to you that cursor is just a loop. Like it just automatically copy and pastes input and output. and for inferencing. Ralph Wiggum is like the simplest, dumbest technique that allows you, when you follow the right principles, to allocate an array with the one task, one objective, and get that goal done. Whilst you can use it in forward mode, as in you can generate some PRDs, look at YouTube, how I generate those PRDs and teaching how to do the Ralph Wiggum technique. You can also run it in reverse to essentially clone businesses. But it actually has a third property. You can Ralph Wiggum a system. We're going to do this today. See, I've been building Loom in a forward mode, exactly like that's on YouTube, building up from specs and demonstrating what a model first company is. There are companies out there who have been building like this for an entire damn year. So let's get into it. But first, let's start with some general theory. For people who don't know, I used to work with Steve Yagi. Steve Yagi is doing amazing stuff. We're mates. And we're exchanging notes because there's only a few people in the world who really get this right now. And it's so sad. We've got this brand new computer. And round about in November, December last year, probably about December, actually 2 years ago, wow, this is 2024. He put forward this diagram. And in this diagram, he basically said, we're working at the wrong level of abstraction. And for some reason, that really clicked in my head. If you look at the bottom right now, you'll see AI coding agents. And AI coding agents. And right now, that's like the human is directly managing the AI coding agent. Like you're sitting there using cursor one-on-one. And I guess people are discovering now with the Ralph technique that it is possible to actually have a manager. And a manager is an orchestrator. The idea is instead of the software engineer working with the agent or cursor directly one-on-one, instead what they should be doing is programming loops. These could be product development loops. These could be bug rectification loops. It could be almost anything you desire. But the idea is you're just programming loops on loops on loops on loops with one goal, one criteria. So it's really cool. So here we go for really the first time I'm showing Loom. Ignore the visuals. The visuals don't matter to me at this stage. The visuals do not matter for me at this stage. I've got an entire branding and design system in mind. There's a reason it's called the Loom. You see, the Loom is, you can tie it back to the Industrial Revolution, the textile revolution, where you had weavers who used to weave things by hand. And then the loom came along. And when the loom came along, there was an uprising and we got Luddites. But as you might guess, I'm not talking about weavers. I'm talking about software developers. So I'm thinking what is like the textile revolution in software development? So we've got two really good researchers right now exploring these domains. They've got Yegi and myself, and ever since Wiggum's come out, other people are creating their own orchestra. This is brilliant. We need to actually rethink about what the best software engineering practices are. Why do we do code reviews? If the idea of not doing code reviews makes you want to Ralph, well, it's really simple. Listen to that feeling and engineer away the feeling of Ralphing. Put your engineer hat on. It's not just set it in a loop and forget and get software. Well, you can do that. I do that, but I've done it. I've got a year of experience of that, so I know the failure domains, so I engineer away those failure domains. If you don't do the engineering, you're just going to get slopped, folks. So Loom, as it is now, is we've got full OAuth, Google, GitHub for now, Magic Login. It's got SCIM, folks. So that means automatic user identity provisioning for things like Okta. So we can automatically, for enterprise, and provision and unprovisioned accounts. This is normally a core enterprise feature. And that was done, like everything I'm showing you here was essentially done with over 3 nights through New Year's Eve. Just before New Year's Eve, you'll see a video on my timeline where I'm like, Happy New Year's Eve, because those 3 nights of basically creating Loom. And Loom, like Gastown, has been built like 4 or 5 times before the community's actually even seen it. So I'm kind of hesitant to really show it what it is now because it's all so raw. It's all so raw, but I'm opening up. I'm opening up. So Loom has this idea of being the loom for automating tapestry or software development. And it has the idea of a thread. A thread is basically an audit trail, what has been done by an agent. And anything that an agent does is kept on an audit history. And that means that you can read in another agent's audit history and then Ralph Wiggum that audit history and load it in as context. It also has repositories. So by default, right now, it is using Git, but it also has full support for JJ. Has full support of JJ. So JJ is like the next gen source control management tool, but they never implemented sync mode. You see, JJ is developed by a collective of really brilliant engineers. One of them works at Google, one of them works at Meta. They both have differing opinions on how it's meant to be done, and they don't want to lock down like the synchronization protocol. That's fine. Full respect to them. So I forked JJ. There is no limits to what I will fork to be able to achieve this goal and outcome. And it's called spool, fitting in with the tapestry theme. So spool is essentially a source control built as a source control that basically uses JJ under the hood for now. But I will diverge. So I'm no way trying to be backwards compatible with anything. I've got a single goal, and that is autonomous evolutionary software and figuring out what's needed to be there. So I can create a repo and I go, yay, repo. Got my yay repo, and then, yeah, you know, this is GitHub. Like, this is the current bleeding edge of like what like source control is. It's just this page and maybe like a pull request thing and what else have you. It's so basic. It's so basic. It just feels old and dated. You know what I mean? Like, I want to, like, when I first got into software development, I used to print out the source code. And I'd sit there with a highlighter. And when I sit there with a highlighter, I would like plan my day. And I'd go, this needs to change, this needs to change, this needs to change. Well, what happens if that's the idea of the future? Like, for anyone saying that Ralph creates problems, well, yeah, but any problems it creates can be solved with a targeted Ralph approach. So maybe instead of like, maybe source control is the way that we actually trigger off a Ralph loop. Like, oh, I don't like how it's doing that repository pattern here, and the SQL is spread all over the place. Sweet. Kick off an agent in the background that identifies those types of patterns. It will come up with a plan, and then you run Ralph in the forwards mode to actually automatically rectify this type of stuff. So some of the ideas I'm thinking about, like what we can do on a design level. And then from there, of course, each one of these would have threads and with a full audit trail of what it's been doing. Which gets me into weavers. In Loom, weavers are the agents. The agents are called weavers. And there's a reason why and all the rest, but essentially what I've done is I've essentially re-implemented E2B. So that's a company that specializes in remote infrastructure for running on agents. I did this just before New Year's Eve. And what it allows me to do is I can start an agent and provision it on remote infrastructure. And then I can assign it a Ralph loop. I read through the Spiffy specification. If you know that, you know that. And I've fully implemented it. Right now, it's just using Kubernetes. Um, I am a firm believer in keeping infrastructure stacks very simple and scaling very vertical. So I'm not even prescribing like it's like Kubernetes or a container. Like for now, it's just the easiest way to me get this up and going and prove the theory. Like if I need to rewrite something, I will. Because it's simple to do now. It's simple to customize software. So I can create a Weaver. And by default, you've got your different images that you can kick off for your remote infrastructure. So let's go to say, let's say Ubuntu. And what this is going to do is going to create a Kubernetes pod on some remote infrastructure. Now, the thing that really blows my mind is this was all like everything you see apart from the visual is just really just vibe coded up from specs using the same techniques I showed on YouTube. And it's able to create the infrastructure. It has full WebSocket backwards and forwards connection to the TDY. It does workload attestation and identity via Spiffy. So essentially, I've also got a primitive here that could be reused for CI, but I'm not even using CI these days. I just push to main. It's pretty crazy. So because this is a live demo, some things are going to be broken because I'm building this with like the Ralph technique, and there's going to be holes and gaps, and I'm just going to be doing this live. So if this doesn't work, I'm going to show you how I investigate it and how I would fix it with a Ralph loop. Now, let's go on to the next things. Of course, you got user profile, etc., etc. But we've got full. I've added like 20 different languages for internationalization because it's now easy to do, which is cool. We've got a full admin panel, and the admin panel, of course, has all the different tools and health. I made a really conscious decision to move as much logic as possible to the server because the server is designed to be hosted on your own infrastructure. That way, if like there's something wrong with an API key or anything else like that, you don't have to like update some sort of client config. You just redeploy the server and all the clients automatically change to a new API endpoint URL for inferencing or a different API key. And the same thing can be said for things like search tools. So a search tool is essentially a tool that's registered into a coding agent. And when it does that, what happens is it will do it like a web search or a Google search. So I have both support for Google and of course for SERPA. So depending on which one you want different data sources from different vendors, you can do that. Now, you probably see the logs chugging away on the right-hand side. What you might not know is these logs, I've got a full audit system. Everything that happens in Loom has full auditing. To give you an idea to the level of auditing, each Weaver is actually an eBPF program. Anything that happens in that Weaver is sent back to the Loom server. And whilst I haven't implemented it yet, forwarding over to Seams. I actually have implemented the functionality, I think. I don't know, we'll run a Ralph loop to just see where it's up to. I definitely wrote the specs for it. And I think it's implemented, I just never really tested it. From there, you get your typical background jobs, like system administrators can actually trigger maintenance jobs like Git, garbage collection, and what else have you. Weaver cleanup is, of course, just cleaning up old Kubernetes pods for whatever reason, if need be. And they're just usual things. From there, we've got something interesting. If you know, you know. If you know, you know. And then from there, of course, we've got our user platform management. So the reason I'll actually get in here, because user management isn't really that interesting, but it is really interesting, actually. So I've implemented I've implemented ABAC, attribute-based access control, not RBAC, ABAC. So I can do very fine-grained filtering on a permission level, whether someone has access to a resource or not, like a source control host, or maybe they've got access to like the admin panel. It's very fine-grained security model, and it supports impersonation. So you can impersonate another user, and it will notify that user that they've been impersonated. And there's a full audit trail, everything that's happened. So this is really handy in, I guess, enterprise support, where someone says, "Hey, it's broken, it's not working for me," and you're like, instead of like getting on a Zoom or what else have you, you're just like, "Can I just impersonate your session?" And then you can impersonate out that user, and you can see all the weavers that they're running. You can log into those weavers. You can help troubleshoot what's happening with them. But maybe that's more of like a second level support type thing. If it's a bigger organization, I guess you normally would have a frontline support team. So anything that a weaver does produces a thread. A thread is the audit trail, what happened, like all the turns that's happened, etc. It's the context, it's the array. You might hear me talking all the time about like when you've got this beautiful context window. Wouldn't it be great if you could just save that context window and reuse it? Threads. Threads. So if you have a problem with thread or a weave or something's gone wrong, you can actually just share it with support. And then anyone with the support-based access permission will be able to basically see what is going on. So it just makes it really easy for enterprise to actually support what's going on and see what's going on. Really cool. Now the visual doesn't look like anything. It looks like crap. I actually need a designer. I'm focusing more on the technical implementations and getting like the whole thing right working and understanding new techniques of Ralph loops. You want to have a peek? It's on GitHub. Full disclaimer, it's a research project. It's built with Ralph. Things will change really, really fast. You should not use this unless your name is Jeffrey Huntley. Do not use it. Not even if you change your name, Dex. Not if you change your name. However, you can have a look through some of the things I'm doing, and I can now use this because the code is available to teach. Like, for example, like I've been doing nixos now for 14, 15 years. I don't know how long. Go find my original video where I'm like, nixos is amazing. I think I was a consultant, a .NET consultant back in the time. And in the infra directory, you'll see some really, really cool patterns. And why not? We're live on stream. Let's have a look at my passwords. Let's have a look at my secrets. So I use a primitive called SOPs. SOPs is really damn cool. Security is meant to be part what you have and what you know. So I'm kind of invalidating a security principle here by like providing it to you. But if you manage to like break the encryption of SOPs, I have bigger problems. And plus they're just vanilla API keys. Later, I'll move all this stuff out. Plus, I've already implemented like HSM modules. Right now, it's a soft HSM, but it's got cloud backing anyway. So, you know, and this is for now, SOPs is everything. But this is a really cool pattern, folks. So I can come into my loom.yaml. You'll see all the API, you'll see all the environment variables needed to run Loom. But they're all encrypted. They're encrypted with the host SSH key, which you do not have. Which means this is useless to you unless you steal my host SSH key. If you do steal my host SSH key, congrats. There's nothing on the box, but I guess congrats. I'll buy you a beer and I'll just rotate the keys. I really don't care because all these access controls are set correctly with the right spending caps. So any breach of this wouldn't actually matter because they're all locked down to IP addresses, you name it. I've gone the whole hog here. Now, the way secrets and SOPs works is really simple. The infrastructure of before I get there, the infrastructure of Loom right now is under a unified theory that you can buy a bare metal machine now for about $1,500 US a month with 192 cores and terabytes of memory. That's damn amazing. Do you know what you can do with that thing? Like, I've been on the front page of Y Combinator more times than I can count on a Raspberry Pi, and it didn't crash because you applied the right systems engineering thinking to it. 192 cores. You spend a little bit more, you get a dual 192 core machine with terabytes of memory. So we can scale up pretty high now because there's a falsehood in software engineering, or at least infrastructure, that I suppose back in the web scale days, what happened was hardware wasn't advancing fast enough. So the only option was really, instead of vertical scaling, was horizontal scaling. And that came at the right inflection point. We got all the cloud vendors selling their options and what else have you, and saying that you need to do horizontal scaling. But if you ever use those platforms, you know their disk IOPS is utter shit, right? Utter shit, and it's so expensive. The same server on AWS or GCP would be costing you easy 10 stacks a month. You can go get it from Hetzner or OVH for $1,500 a month, and it just goes up, and it's amazing. We can get into BCP type topics later and how you handle all that. I thought a lot about it, and there's primitives built in for this. I built my own file systems. It sounds out there, but I needed to. Cool. I'm going to go take you a walk through nixos quickly. If you've never seen nixos is the power tool of infrastructure. You should use nixos for any of your next AI projects because it has these primitives, and these primitives can be used to declaratively define a server, and that same definition can build a Docker image. It can build a QEMU machine. It can build an LXC container. It can do it all. Plus, it's the only safe option to actually run agents with sudo. Loom, to bootstrap Loom up, the agents deploy on the server using sudo. And it's only possible because of nixos. So let's have a look into nixos really quickly. So right here, I've got all my different modules. And let's say that you want to configure fail to ban. It's like in nixos, you go like services.fail to ban, enable equals true. Really simple. They've got this beautiful DSL. Beautiful DSL. The language is a little bit something, but like the consistency on how to configure things is like peak, absolutely peak. Here we connect back in our secrets. Here's the SSH key that's used to unlock it. In Loom itself, as it is now, is just a singular server. Very big, beefy server. And I import my modules. Cool, and they configure all the different things of that server. I configure my IP address. I don't care if you see my IP address. You don't get hacked because you have the IP address. You don't. You get hacked because you're other things. And then even then, so what? You get the source code. It's on GitHub. Congrats. There's nothing else on it. Cool. We got our init-rd configuration, grub. But this is the interesting thing. This is how I configure my secrets. And I configure the ownership of these secrets for each individual service, change the file permission, etc. So when Loom is deployed on my infrastructure, it applies this nixos config, and it will decrypt with the host SSH key and deploy the secrets that I need to actually run Loom itself. Now, everything I'm talking about here is not prescribed. It's not prescribed at all. Loom also runs as a Docker container. This nix expression generates out of a Docker container. But doing continual Docker container rebuilds is just such a slow development loop. I'm focusing and optimizing on speed. And the best speed is you push master, and then it auto deploys in 10 seconds. Zero code review. I know what you might be thinking. This sounds mad. It kind of is, to be honest. It kind of is. But what happens is I get to feel the failure domains. Instead of trying to avoid failure domains at all costs and slowing down the development loop or the Ralph loops, I'm feeling these failure domains. And when I see them, I get to categorize them of how those types of failures happen, and then I engineer them away. If the idea of running Ralph on your code base makes you want a Ralph, listen to it, and then engineer those concerns away. So when I'm doing my development, I push master from the agent. And what happens is there's a nixos auto update script. And essentially it tracks, I think it's like every 10 seconds, it does a git pull. This is the early days while I'm still on GitHub. There'll be a point where it's bootstrapping itself when I'm not going to be on GitHub anymore. If you want to look at the Loom source code, you're going to have to look at that on Loom itself. Cool, auto update, it does a switch, does all the things that Nix does. Let's have a look at this. Actually, before we do, let's see if this Weaver actually created. Yay, the Weaver created. I wasn't so sure because I was doing some really deep internals at eBPF a couple of days ago. It's been a couple of days since I looked at this. It's logs, so the log stream's not working. That's okay. Software is now clay now. Get it to a position and get it kind of working. And then when you find problems, run another Ralph loop over it and then engineer back pressure to stop those failures from happening again and making sure that new Ralph loop doesn't actually break existing functionality. So here we are, we're logged onto a Kubernetes pod. This Kubernetes pod is of course running on a Kubernetes cluster. There's a WebSocket between the Loom server and that Kubernetes cluster directly to the pod. All this stuff was vibe coded, folks, from specs using the Ralph loop. It was just me driving by hand, and when I got a high degree of confidence interval that it was getting the things right, I just let it rip and just like went AFK, started DJing over New Year's Eve. How crazy is that? You've got a full WebSocket. Now, Weavers is a double overloaded term. A Weaver is both remote infrastructure, or a pod, like it's running an agent, whatever, but it's also a command line. Like the CLI for running Loom, the CLI for running an agent is also called Weaver. And that Weaver can run on Mac OS, Linux, Windows, all CPU architectures. If you have a look in there, you're going to find some really cool infrastructure patterns where I cross-compile using the Zig toolchain for all these CPU architectures from one big beefy box after every deploy. And what happens is, if you come across the bin, for expediency right now, I'm not actually compiling the Windows binaries and deploying them. But what happens is when a Weaver is deployed, through Spiffy and their testation, if you're familiar with cloud and init type topics, you can pass like customization variables to your kernel or to a container. So this is where it gets fun. When a Weaver is provisioned, you need that Weaver to connect back to the Loom server, so you customize that during the provisioning via the API. However, how does that Weaver or that Kubernetes pod speak with a Loom server? We should assume zero network connectivity. Well, the answer is there. Loom contains tailscale. It's all WireGuard driven. It uses the tailscale public derp maps. Now, for my friends at tailscale, I love you. I did not clone you in the Z80 style, okay? I just kind of know WireGuard. So we now have a full implementation of WireGuard where the Loom server is essentially the broker. It uses the tailscale derp map. So when you provision a pod, what does it do? What you do, you pass across some sort of a boot initialization identifier, Spiffy, by a Spiffy. And what happens is when the Weaver starts up, it's able to broker network connectivity via WireGuard. But that's not even the fun part, because we got this remote infrastructure, and I'm talking about, like, I want to reimagine what an IDE is to the future. Well, even if I get there, as I get there, I still need the IDEs of today. So the question is, how do you repair a weaver or an agent that's gone astray? You need network connectivity to it. This is why the weaver is also a command line binary where you can run it like just locally if you wanted to, and then it uploads the thread. So you don't actually need to provision remote infrastructure via the weaver command. But it also serves as a WireGuard client. So we have this three-way network connectivity from my computer to some random data center somewhere with no direct network link, routing via Tailscale/WireGuard, brokering connectivity to the main server, and all these three things are able to communicate with each other. And there's full isolation between all these different weavers and what else have you. It's cool. It's really, really cool, folks. And now that I've got network connectivity, I can do things like port forwarding a running web server that's running in a weaver, and I can go check it out, right? I can run a Ralph loop in a weaver, and it says it's done. And then the port forward is there on my local machine, and I can have a look at it. Or maybe I port forward that one from one weaver to another weaver, and then that weaver has a Ralph loop that's just done system verification on that. And then I pass the thread outcome back to the original weaver. And all of a sudden we've got these meta Ralph loops. So yeah, you can SSH from your local computer. You can SSH into remote infrastructure, any one of the weavers, and rescue them. You can use the VS Code plugin or just the normal, what else have you. It's just SSH, but it's all brokered. This is an infrastructure play, folks. I'm imagining what everything is and can be. Cool. So I've got my remote infrastructure. It still blows my mind that this is damn possible. Seriously. A lot of this was built in 3 days. It's not the first time I built it, and I didn't have the specs when I built it. There was no cheating. I just wanted to compare, since the last time I did it, with like Sonnet 3.5 and then Sonnet 4. I wanted to try it with Opus. Wow. Wow. Okay, so let's kick this off. Let's have a look through the source code. Let's bring this in. Okay, we're now on the Loom server. Move this up so you can see, yep, there we go. And then you go like this, city crates. This is what's been implemented in 3 days. I mean, like, if you look at that, and maybe if I just make it a little bit smaller so you can actually properly see how unhinged this is. Like, it is cooked. So what we got right now is all this functionality. Some of it's hooked in, some of it's not, because I developed it in separate loops. They're not integrated. So the biggest question really is, can I run a Ralph loop to identify things that are not locked in and connected? Or maybe functionality is connected, and all I need to do is think deeply about what the right Ralph loop is to be able to put this entire system under test and come up with a plan. If I've got a plan, you know where this goes. Cool. So we're on this machine. Machine's cool, big beefy thing. Got new CPUs on the way, so this will go even faster. And let's do, for now, we're using Claude, where we can get the cheapest inferencing. That's what matters right now, because there's no difference between any of the coding tools. Cool. Now, I'm going to demonstrate the first thing of like the first loop. One of the loops I normally do is the server deployed. As you start engineering these types of concerns, you start thinking in higher and higher level of abstractions. These are programmable computers. These are programmable computers. So right now it knows about the nixos auto update script. Notice how it didn't do any hill climbing. It did not do any hill climbing or like failed tool calls. It's straight in there and it's going, yep, I'm going to look at the version that's deployed in the server. I'm going to look at the server status. It's going to look at the remote host. And yeah, the server's healthy. Loom is healthy. Okay. Now I can go study the Loom server logs for errors. And it automatically knows about that I use journal control. It's using sudo, folks. Only possible due to the magic of nixos. Now, as this is out of Bootstrap, it won't be using sudo, folks. This is just the early stage. If you know compilers, you're essentially bootstrapping and tombstoning from one thing to the other. This is the fastest way I can do my software development practices right now. Speed matters. It's the wheel of it's the speed of the wheel and how it turns that matters. So that means how fast the generation works. Well, there's not much you can really do about that unless you do concurrency of lots of weavers like OpenAI, Codex. You've got a lot of control over the back pressure. This is your tests. This is all these different things. If you have a look at my pre-commit file, you'll see a lot of tricks in there where I start engineering back pressure. I'm doing that, and that approach is because Loom isn't at a sufficient level where it's bootstrapped, where I could do some coordination between 2 or 3 weavers and then Ralph, etc. Cool. Let it have a look at the logs. It's probably going to find nothing. Let's have a look. You know what? It's going to take forever. Oh, wait a sec. Oh. Oh. This is interesting. So if I wanted to fix this, the first thing I would do would be like study specs index.md. Index.md is like this highly optimized lookup table that works on the theory of essentially if you can tune the search tools and the read tools, essentially you start thinking about cache misses and cache hits. Every time a tool call fails, there's a chance for tuning. If it fails, that's a cache miss. If it succeeds, that's a cache hit. Now, cool, I've now pinned the context that I want to do. Yo, what was the problem that we had? What was the problem we had? We had... I'm going to throw this one out to everyone who thinks prompts matter. So we've pinned our context window. I've given it a goal. It's describing the application. Now we're going to do our first loop. And we're going to do an investigation on what is wrong here, why it's working, why it's not working. But I guess while that's going, because it's going to take a while, let's do the mega loop. Let's do the mega loop. And then probably we'll just throw in some tunes. And we'll have a look at it tomorrow. Okay, let's start Claude Code. Actually, let's do a feature demo before I do the main thing. Study the pins, put the pin in, spec/readme.md. This will customize and essentially program the LLM and know exactly what's going on, what the requirements are, and like some shortcuts, aliases like deploy server, all the rest. Let's allocate that the context window. Yo, can you use the Loom CLI to create a remote weaver? So now I'm actually doing a form of a Ralph loop by hand, and it's not just for building, folks. It's not just reverse engineering. Everything is about engineering these loops. So let's say I suspect something's wrong with some functionality. For example, provisioning a remote weaver. I could do it just a prompt like this and then drive it in a loop. And here we go. It's compiled it. It's going to create the remote weaver. It's detected there's already a weaver running. It's creating that weaver, which means it's remote provisioning to remote infrastructure, very similar to OpenAI Codex. And that's just going to be cooking away. So while that's going in the background, hey, that's good. It's done. The weaver's done. Crazy, absolutely crazy. So the next loop is, I guess, let's take it up a notch. Actually do it. Let's do it. Let's allocate the array with the pin in. Cool, now specialize my context window to know all about my application. This is model first companies. Corporate doesn't have this backing. They can't just say deploy my server. No, because they haven't built with intentionality to be able to run these loops. Cool. The weaver's created remotely, TTL 4 hours, I can connect to it, etc. Destroy this weaver. Remember, this context window had a singular goal. The singular goal was to create a weaver, and it's now created it. And because that's pinned in the context of like what it needs to do, it knows about the identifier. So I can just say delete the weaver. I don't actually need to specify any type of identifier because it would just work. Just work because I've got a singular thing and a singular focused array or context window. Cool, weaver is now deleted. Cool. Cascade of failures. Okay, each sidecar is setting batches with thousands of events. This is my eBPF audit trail. Like, okay, the buffer is growing. Let's do the low IQ, just saying, let's explore option 2 and 3 and 3. Let's discuss. Cool. Okay, I have now, let's do the loop. Okay, I want you to come up with a plan that tests all the Loom server API endpoints that we will use for a Claude Code session separately to this. It's important to cite line numbers of specifications and the source code that is under test. I'm just making this up on the fly. I want this strong linkage to increase the cache hits rather than misses. Optimize in search tool. Search all the code as needed using up to Claude Code. I can only ever do about 10 sub-agents. My personal best is 200 sub-agents in other products. So it's one reason I get off Claude Code, because it's just not expressive enough. Then write the test plan.md as bullet points. Let's let it rip. So what this is doing is, instead of me going around clicking on all the UI to verify functionality, what we're doing is we're generating a plan to run this infrastructure under test with a Ralph loop. So Ralph can be used in forward mode to build, it can be used for testing, it can be used to drive loops for system administration. There's no really limits to this. It's why it's just easy to dismiss like a loop. Just remember, the tool calling revolution is just a loop. Sometimes the most simple primitives are some of the most powerful ones. Cool, let's have a discussion. Okay, let's have a look. Let's look at the implementation currently. Current architecture, ePPFs, event processor, accumulates on the vector, buffs to 100. You know what? Whatever. I can always undo it. I can always run a Ralph loop to evolve this later. I can run loops to target and analyze security aspects of this thing. And then with myself there with watchful oversight, I'll have a look at it. But for now, we're live, so I'm not going to put too much effort in this thing because I know I can just run another loop. So this will take a little bit longer. Whilst it's cooking along, I guess I should show some pretty things. Cool, so there's a VS Code, there's an IDE VS Code extension. I'm still two minds whether even bother doing some more loops and getting this over the line with the VS Code extension because of this reason. The Weaver supports ACP. The protocol is provided by Z that essentially allows any editor to connect with any agent. It's in there, it's not integrated, so maybe I do the extension, maybe I don't. I'm not sure what VS Code is like for ACP. I need to investigate. Oh, something I forgot about. So the idea of Loom is more than just GitHub. And I mentioned that it's about anything I need to do. Well, I don't want to always push main and master. Maybe I want to have some sort of back pressure and some sort of pre-check CI, or maybe the alternative is I still push main and master, always. But what I do is I roll them out in feature flags or feature experiments. So, you know, that old engineering principle, that can be automated now. So I'm thinking like it's like once a Ralph loop is done to actually finish software development, well, that would kick off another Ralph loop that would carefully implement feature flags over that, whether it's on or off. And then once that's done and it's deployed, because I showed the deployment loop, the end result of that is I could create another Weaver or another loop that had a look at the telemetry or the metrics from the server for that particular feature. And it could decide if it needed to turn it off. Because it still takes time to do these loops. Inferencing is not instant yet. So the idea is automatic introduction of feature flags, automatic removal of feature flags, you name it. I really don't want to be involved in the deployment of this thing. Now I mentioned analytics. On my last stream, I re-implemented an implementation of analytics similar to PostHog. Now the reason behind that is because I want to move into essentially agents being able to modify product features and be able to do A/B experiments and what else have you on product features. It's not just like if then else feature flags. No, it's like full on product analytics. Full on product analytics. We have a very basic I've got a very basic TUI, but it's kind of broken right now. But then I really don't care if it's broken because I just like run a loop in the background to fix it. It's really weird. As the models get better, the more powerful these techniques get. So we really need to be thinking about orchestrators and like how do we do coordination between all these types of loops, because the loop primitive is not going away, folks. Not going away. Cool. We're done. Let's do the Ralph loop. Let's do the big sut Ralph loop. I've never done this before. I've conceptualized that it was possible to run an entire system under test. So maybe we're looking at something a little bit different to Playwright here. Rather than creating these like fixed tests as such, maybe we've got a new branch here of like different ways that we can run these tests, and we're connecting all our different MCPs and what else have you, if need be, all the different tools for running Chromium headless and what else have you. Now I'm guessing this prompt is going to be underspecified because I think the model's going to lean for authoring the tests or checking that the tests are there. Let's let it play out. So I'm probably going to kill out of this rough loop. And instead, what I'm going to do is make it very clear it needs to drive the public API via the Weaver command line tool. Let's see how it goes. I'll be back. Let's see how it goes. So as expected, it is leaning towards inspecting the existing tests. Is that leaning towards writing code? Let's kill this out. I could do this and it could be exercised under the integration testing code, and that would be great, but that's not the behavior I want for this stream. Let's see this one little tweak. We'll program the computer. Let's see what we can do, folks. Watch out, just one simple tweak to the loop. That's because it's so generic, you can just get crazy outcomes. So hopefully this will now pin the specifications. It's done that at the top. It's now one of the key principles of the loop is to pick one, so it only has one goal for it to do. And I've clarified my prompt that it should run a full integration test, and it's doing it. using the loom weaver CLI, which is the coding agent, but can also run remotely. So for each one of these functionalities, it's going to create remote weavers and all the rest. Oh, I know what I forgot. Cool. I know what I forgot, folks. This is why you should run around by hand. You should watch it. Study the Loom server journal D for errors when you have issues to be able to troubleshoot. You may add temporary logging as needed be for usage with journal D logs for troubleshooting if needed. Cool. You just play with the computer. You program the computer. So here I'm giving a permission that I'm giving it a hint. If at any stage it does a curl request and I get a 400 or 500 or something wrong that doesn't match my specifications, it should study the server audit log, and it has permission to automatically deploy. Has permission to automatically deploy. I might do this recklessly, actually. I might do this recklessly for the sake of the stream. So now I'm giving it permission to test all these things via curl and the official CLI. It should update the test plan when it's done, when the testing is done, if it all passes. But if it enters into a failure scenario, then it has permission to add temporary logging as need be. Oh, actually, I can tweak this a little bit more. I've got an idea. Before and after. Let's give it a yours and mine. Let's give it a yours and mine. I was able to see what the logs were before for the errors and then afterwards. So it will run this step twice now. Let's kick this off and I'll be back in a tick. I'm going to go check Twitter. If there's any questions you might have while I'm here, I will take the opportunity to answer them. Just like reply to the broadcast tweet. Otherwise, I'm going to wrap early. I'm tired. It's been a very long week, folks. Very long week. All right, welcome back. Let's have a look what it's doing. Let's scroll the way back. So with my first loop, I told it to pick one off the list. We want to put the entire system under test, as in not isolate or whatever, it's the entire damn system. We've given it permission to deploy the server. We're not serving users right now, and I haven't integrated in the feature flag and the stage rollout deployments. That's coming, so soon what I'll do is I'll change that prompt to say, hey, you need to use the skill or what else have you to roll out these features automatically, but like in a feature flag, and then you turn it on and off, and some other weaver is controlling that aspect. I told it they should look at the logs before it makes a change and after a change. So that way it's got permission to deploy, to troubleshoot, but when it'll be troubleshooting, it will just be adding extra logs. Because what we're doing here is a Ralph loop, not to actually fix the problems, it's to refine and create another plan. And when we got that final plan, when we know what's actually broken, then we take a different approach on how we actually going to do a Ralph loop to actually fix those problems. I'm going to sit down, I'm going to have a look at the class of problems, I'll look at the code that's broken, and I will come up with a plan to target maybe just one or two. Maybe there's some commonality, maybe there's some like module design is wrong or what have you. And I'll target just that. I'll kick off a plan just for that. Same way as if I was developing product specifications, I'd pin the context or the idea of a model first company. And once that context is pinned, the end outcome is I can then run a loop and set it on a task and goal to do something. And that do something would be over. We don't need to do investigation, but what we can do now is a resolution loop. So let's have a look. It's found the credentials, sees my token, I don't care, there's nothing on the server, if you use it, congrats. Checking the me endpoint, cool. A little bit of hill climbing here. So I could probably tune my prompt. I could tune my prompt a little bit more. So I don't get cache misses. And it's going to try to create a thread. It's going to try to delete a thread. It's going to exercise curl. That way we can isolate if it's an API error or it's a client implementation error. Cool, it's running. We've got a status. So these things are now working. So now we've got actually an automated way to do system verification tests. There is no reason why this can't be a continually running thing in the background. Maybe this type of approach replaces CI, or maybe it replaces a lot of the manual scripting that we used to do for testing endpoints and what else have you. But maybe it's just like property-based tests or like snapshots, like VCR type tests, integration tests, unit tests, whatever. Like, we're engineers, we pick the right thing for the right job. Cool, it's tested, it's working, and it's more integrated than I expected. Health endpoint's working, thread search is working, key finding. There's a bug here. So this is telling me this is an opportunity to tune my harness prompt. This is actually something I really can't do because I'm using Claude Code, so I'd have to put it in my agent MD, but in Loom itself, I'd be tuning this aspect to get rid of like multi-line bashes and etc. Just do separate tool calls. That's it for now. It's a long stream. It's still very early days. It's very fresh, but the idea of running thousands and thousands of agents with a single task and goal backed by some specifications is what Loom's all about. And it's not just like a GitHub. It's I'm not even sure what it is because it's moving into the product space and essentially like a loom is really cool, but like the idea of autonomous software factory is much cooler. Anyway, see you folks.